Time now for our weather chat, and today we are talking about what a wake low is. It's actually something that we saw here in Central Texas this morning.
Yeah, it's a very interesting and unique mesoscale low pressure system. It's impossible to forecast. It's something we do when we nowcast, which is when we're looking at the current conditions and seeing what could come from it. It forms behind the storm complex, so when you have winds ahead of a storm, it's that gust front. When you're in the storm, it's the storm winds, and this sometimes can happen behind the storm.
Yeah, absolutely. Like Tommy said, we can't forecast ahead of time when it happens. It's just something that kind of creates itself behind a line of strong storms. That's what we had this morning. Because I saw the wind starting to tick up 40, 50, 60 miles per hour in parts of the Austin metro, I said, hey, something's happening here, because the storms are already east of where we're starting to see the winds come up. And lo and behold, it was a wake low.
Yeah, through the night I was checking the radar, and around, like, let's say 5 o'clock, I step outside and it sounded like there was still heavy rain. And I open up the door and I'm like, all right, wake low season, because it's just trees blowing and bending. There were branches flying all around, and it could definitely take a lot of people by surprise. The dynamics and physics of it is always fun to look at least from a weather nerd perspective.
Yeah, absolutely. This was our radar at 3 a.m. this morning, and so you can see a lot of this kind of heavy on the eastern side of the viewing area. But what happens is we see sinking air on the backside of the complex of storms. That sinking air then warms significantly, and you get this pressure gradient between the high pressure over the storms and the low pressure that develops behind it. Now, the bigger the contrast, the stronger the winds between the two. But it is very interesting to see, because, you know, Tommy said mesoscale, almost like microscale, if you will. Like a mesoscale low is typically a couple counties wide, whereas we're used to, and you're probably used to us seeing synoptic scale lows, which are, you know, could be a couple states big.
Yes, so that's why, right, when you see the high pressure, you're like, wait, well, high pressure, I thought that was something that's more of just a sunny day, but instead, no, it's the atmosphere trying to center itself and not be so lopsided, and that sinking warmer air, right, it becomes less dense and it lowers that air pressure. When that air pressure is lowered, it's trying to even itself out, and that's what's causing some of those winds. So, you know, in the storm itself, we'd say maybe there were, in this complex, 15 to 25 mile per hour gusts. Behind it, you said 40, 50, 60.
Yeah.
So, you know, that's why after a big storm complex like this, that's where those winds can really begin to ramp up.
And sometimes you can see a jump in temperatures, which we observed at the Austin-Bergstrom Airport. Austin-Bergstrom Airport wind gusts went up to 60, 62 miles per hour, and the temperature shot up to the 70s, whereas most of the temperature sensors around it were still in the 60s. But sinking air is warming air, right? So that's why that temperature kind of looked a little wonky on the maps this morning.
Yeah, and still a bit of a light breeze too in our eastern counties. I'm sure that will slowly go down, in a rather calm day today, but these can happen, and don't be surprised, maybe in the next week or two we could see another one.
It's a small version of what our planet is doing every day, right? The wind and these big storm systems are our planet's way of trying to balance itself out and create equilibrium. And as a result, it's, you know, the chaoticness of winds, storms, whether it's winter or weather, tropical, it's the Earth trying to balance itself out, and as a result, we get weather out of it.
Yeah, we'll have more of an in-depth look here in the next few hours, which you can find at KXAN.com.
Sounds good. Okay, we'll be back with more.